Hi, in this video, we're looking at the concept of matrix. During the course of this video, we're looking at the definition of a matrix, we're looking at the order of a matrix, and lastly, we're looking at the position of elements of a matrix. Then in subsequent videos, which will be part of a larger series on everything matrices, we'll be looking at the types of matrix, we'll be looking at the addition and subtraction of matrix, we'll be looking at the scalar multiplication, and also the matrix multiplication. We'll also be looking at the determinants of a matrix, how to find the determinant of a matrix, the cofactors of a matrix, the adjoint of a matrix, the inverse of a matrix, and how to solve a system of simultaneous linear equation using the concept of matrix. Also, we'll talk about the Gaussian elimination method and the Cramer's rule. So do well to stay tuned. It's going to be, or it promises to be, an interesting series on everything matrices. So moving on to what we have for this video, what exactly is a matrix? Of course, the word matrix and matrices are just plural forms of each other. So when we have a single matrix, we call it a matrix. And when we have multiple matrices, we call them matrices. So what exactly is a matrix? So a matrix is simply a rectangular arrangement of numbers, symbols, or expression arranged in rows and columns. So when we decide to arrange numbers, symbols, or expressions in rows and columns, then we're talking about a matrix. Now, of course, just like sets, a matrix, when in naming matrix, we name them with capital letters. So let's say I have matrix A. From our definition, we said a matrix is simply the rectangular arrangement of numbers, symbols, or expressions in rows and columns. So let's say I have something like this. So this is a matrix. You can say it takes the form of a rectangle, or it looks like a rectangle. Now, this is not to say all matrices will look like a rectangle. Of course, some look like a square, but of course, if it's not a square, then definitely a rectangle. So we'll talk more about that when we look at the order of a matrix. All right, what else should we know in our definition? The horizontal arrangement. The horizontal arrangement, we can call it the row arrangement or the row picture. Row arrangement. Row arrangement. So this is a row arrangement. So you can see that in this matrix, 2, 1, 3 constitutes the first row, 5, 4, 6 constitutes the second row. And then the vertical arrangement, to constitute the column arrangement or the column picture. Column arrangement or column picture arrangement. Okay. So you can see row and column. So from our definition, we're arranging numbers, symbols, or expression in rows and columns. The horizontal arrangement is the row arrangement, while the vertical arrangement is the column arrangement. All right, so moving on to the order of a matrix. The order of a matrix. Now, the order of a matrix is simply how we describe a matrix dimensionally. So if we were to describe any matrix dimensionally by its dimension, then we're talking about the order of a matrix. And this is always equal to the number of rows by, so we use this symbol for by number of column, number of rows by number of columns. So if we want to describe any matrix whatsoever, so this is how we describe it. We know the number of rows first, and then we know the number of columns, and we combine it with this symbol X. So in this example, or in this matrix A that we've written, if we were to write the order, you can see that here we have 2 rows and 3 columns. So the order of this matrix will simply be 2 by 3. So 2 by 3. All right, so let's just take more examples concerning or involving the orders of matrix just to see how far this is clear. Okay, so let's say we have our first matrix. So this is 4, 5, 2, 7, 8, 8. Okay, so number 2, 2, 3, 6, 7, 9, 0, 1, 1, 2. Okay, number 3, 4, number 4, 5, 1, 3, number 5. Okay, so let's just take this 2, 4, 6, 7. Okay, so 5 matrices, and then we are being asked to find the orders of this matrix. The order. Remember, we said the order of a matrix is simply to tell us or to describe the matrix dimensionally. And in order to describe a matrix dimensionally, we need the number of rows by the number of columns. So let's take a look at the first one. You can see this first one. So we have, this is one row, second row, third row. So we have 3 rows by 2 columns. This is 1 column, second column, so 3 by 2. So this matrix is of the order of 3 by 2. This matrix has 1, 2, 3 rows. So this is 3 by, so another 1, 2, 3. So this is a 3 by 3 matrix. Why this? This one has just a single row and a single column. So this is a 1 by 1 matrix. This one has a single row and 3 columns. So this is a 1 by 3 matrix. Why this has 2 rows and then 2 columns. So this is a 2 by 2 matrix. I hope the concept of the order of a matrix is clear by now. So moving on to the last thing that we have to talk about for today, in order not to make this video extremely lengthy. That's the position of elements inside a matrix. Okay, so let's say we have a matrix A equal to, so we have 2, 3, 6, 7, 8, 9. Okay, now if I want to call out each element inside of a matrix, each element inside of a matrix have that unique identifier. And how do we identify each of these elements? We simply use A, I, J, where I is the row number or its row position and J is its column position. What do I mean by that? If I were to take 3 now, so which this element 3 is in the first row, we consider it is in the second column. So if I were to write this matrix A in its unique identifier mode, you see that this matrix, since it is a 2 by 3 kind of matrix, my matrix will have a unique identifier like this: A11, A12, A13, A21, A22, and A23. So you can see, we already said this 3 is in the first row and second column. If you look at its unique identifier, A1 signifies first row, number 1 row, and 2, the following 2 describe its column's position, hence A, I, J. So if I were to call out, let's say 8 now, so 8 will have a unique identifier of A22. So let's try and take another matrix. Let's say matrix B. So we have 3, 4, 5, 6, 7, 8. And then I say, okay, what's the position of 6? So 6 will simply be a member of B22 because it is in the second row. This is the first row, second row, third row. So 6 is a member of the second row and then a member of the second column. So this is how we call out members or elements inside of a matrix using A, I, J, or A substitute I and J. So the I will be the ith row, while J will be the jth column. So I hope this makes sense. So matrices is simply the rectangular arrangement of numbers, so in rows and column. And then to call out the members of the matrix, you need its unique identifier, so which we've written like this. Now, next video, we'll be looking at the types of matrix that we have. So do well to stay tuned, and of course, share the video, like, and also drop your answers or comment in the description box. Thank you, and bye-bye.